Hello, hello. Hello, welcome to another math video, grade 6. This is the lesson for Monday, March 30th. So I am pre-recording it, so you will have it available to you on Monday to complete and watch for your preceding worksheets. So this lesson is going to cover first slides that I have here are converting improper fractions to mixed numbers. We are also going to cover multiplying improper fractions by whole numbers and Euclid's greatest common factor and simplifying fractions. So today's lesson is basically, let's call this video everything fractions. Okay, we're covering everything fractions today. If you want to know about fractions, you're where you need to be right now. Okay, so let's begin at the top. Converting improper fractions to mixed numbers. So there is a great, very thorough definition from dictionary.com on what an improper fraction is. An improper fraction is a fraction in which the numerator, which many of you already know is the top number, has a greater absolute value or degree than the denominator, the bottom number, such as 7/3 or 7/3. These fractions are equal to or greater than 1 whole and can be converted into mixed numbers. To convert a fraction to a mixed number, divide the numerator by the denominator. The quotient becomes the new integer for the mixed fraction, and the remainder is the new numerator. The denominator remains the same, and the new mixed fraction results. A mixed number is a whole number and a proper fraction represented together. It generally represents a number between any two whole numbers. So I love that definition. It's a very thorough definition from Splash Learn. Okay, so for the whatabouts, we covered that for improper fractions. Now let's get to understanding these improper fractions. Okay, let's dive deeper into how an improper fraction is calculated before we take the second step of converting improper fractions to mixed numbers. Let's look at this diagram on the right. So as you can see, I wanted to represent two pizzas. One pizza has no toppings on it. I chose that color because usually cheese is orange or yellow, and it has no toppings on it. And I wanted to denote the slices that are green as broccoli slices. With that said, let's go to the paragraph. So what if we wanted to separate the no topping slices from the broccoli slices on these pizzas by representing the no topping slices as the numerator in an improper fraction? I apologize for having that is not a singular noun, it is a plural noun, and I had it as this pizza. We're talking about these pizzas. Okay, in the second paragraph, you first need to count the orange slices, which represent the no topping slices, which I just talked about, to find the numerator of the improper fraction. Let's count 1, 2, 3, 4, 5. There are 5 no topping slices. Thus, the numerator is going to be 5. Okay. Next, we have to count all the slices for one pizza. Okay, so the one pizza, we don't have to say two pizzas. Okay, because if we did that, we would be representing the whole number as all the parts. We want the general part. Okay, you might not understand what that means yet, but all you have to know is right now you are counting the no topping slices, and then you have to count how many parts are in one whole, represented as one whole pizza. So we see that there's 4 parts in a whole pizza, but we also see that the parts of no topping slices, there's 5. So let me read this paragraph next. we have to count all the slices for one pizza, which we just did. We found it was 4, to find the representation of the whole part, in this case, one pizza. If you can count all the slices of one pizza, you get 4. Thus, the improper fraction for the representation of no topping slices is 5/4, pronounced 5/4. Okay, let's go to the next slide. Next, converting the improper fraction to a mixed number. Number 1, let's take the improper fraction from the previous slide, 5/4, and convert it to a mixed number. 2, first we need to divide the numerator by the denominator. This looks like 5/4. 5 divided by 4. Think of this as a question. So how many parts can 4 make up? So how many parts of 4, right? Okay, and this was written incorrectly. Typo because I typed fast. How many parts of 4 can make up? Can make up a whole part of 5. That would be 1 part. Thus, 5 divided by 4 gives a whole number quotient of 1. But there is a remainder of 1, since we still need to represent that remaining value, which I'm going to talk about in the next step. Number 3, the remaining value is represented as the numerator now in the mixed fraction. In this case, 1 is the numerator in the new mixed fraction. Number 4, the denominator remains the same, so it is 4. So as you can see, 5/4 as the improper fraction in the mixed fraction, right next to the whole number, the denominator will be 4 still. That does not change. The denominator does not change. 5. Now we have put it all together. 5/4 equals 1 1/4, or you could write it out as 1 1/4. If you look at the previous slide, you will find that we, in fact, have the most perfect numerical representation of the value of the no toppings slices. So hopefully this lesson helps you understand improper fractions and how to convert them to mixed numbers, and was straightforward enough that you can put this into practice yourself. So the next part of the lesson, now that we covered converting improper fractions to mixed numbers, talked about improper fractions. So the last part of this lesson that I want to talk about, actually there's 2 more parts, I apologize, 2 more parts. So the next part is multiplying improper fractions by whole numbers, okay? So let's go to the top of the slide here. We have multiplying improper fractions by whole numbers. So how do we convert an improper fraction into a mixed number if we are asked to multiply by a whole number? Well, we first have to start by creating a multiplication sentence or equation. Let's say we have 1/5 times 10. We would have to convert that to a new properly formatted equation. The new multiplication sentence would read 1/5 times 10/1 equals what? Since 10 is a whole number, the denominator will always be 1. Okay, page 3. So what is 1/5 times 10/1 equal to? So I am going to walk you through the steps. If you go to the right-hand side of the page, look at the bold lettering. First, multiply the numerators. So if you look at the pattern here, and I wrote the equation horizontally, but you should be able to, let me see if I can just type it. So like essentially what you're doing is you see how the 1 is the numerator there and 10 is the numerator in this fraction. You would take that 1 times 10 right there equals 10. So 10 is the new numerator. Then multiply the denominators. As you can see, 5 is on the bottom here and 1 is on the bottom here. So multiply the denominators. 5 times 1 equals 5. 5 is the new denominator. Finally, divide the numerator by the denominator. This will give you a division equation that reads 10 divided by 5 equals what? 10 divided by 5 is 2. So your answer is 2. So that was a quick example of multiplying improper fractions by whole numbers. Hope this helps in your worksheets and your homework. The next slide we are going to go to is Euclid's greatest common divisor and simplifying fractions. Euclid's greatest common divisor. Here is a fun fact. More than 2 millennia ago, Euclid, so he was a famous mathematician circa 300 BCE before Christ, describes a method for computing the greatest common measure of two numbers. Now notice our numbers is in parentheses because GCD, Euclid's GCD algorithm, can be used with fractions, it can be used with integers, but basically the point to bring home is that Euclid's greatest common divisor is used for computing the greatest common measure of two numbers. And today we name our modern iterative algorithm for calculating the greatest common divisor of two numbers after him. Okay, next text box. The greatest common divisor is the largest number that divides both A and B without leaving a remainder. So A and B in this case represent the numerator and denominator for this lesson and simplifying fractions. And I incorporated a couple diagrams there. Pretty cool from Google Images, free images, so you can see. So some people, when you are factoring, you can do a Venn diagram, which we are going to talk about in the next slide. So I don't want to go off and talk about that yet. But this is just a very cool visual representation of Euclid's GCD algorithm. And I think they are just absolutely beautiful to look at, as math is beautiful if you really think about it. So for the next slide, let's tackle these unsimplified fractions. So step 1, what are we going to do? We are going to be factoring. So first, you are going to want to factor the numerator 18. As you can see, the numerator is always a number at the top of the fraction. We know 1 times 18 is 18. So the first factors of 18 we will list, not last, it was spelled wrong. Okay, we will list as 1, 8. Next, think of the multiplication tables for 18. So go up to the factors of 2. 2 times what is 18? 9, right? So our next factors to jot down are 2, 9. Then 3 times 6 equals 18. So we have 3, 6 as additional factors of 18. Now let's go over here. No remainder exists when factoring. So this is why I stopped here at 4, since 4 cannot evenly be divided by 18 without, of course, getting a remainder. So next you have to order the factors of 18 in chronological order. The factors of 18 then will be 1, 2, 3, 6, 9, 18. Now let's factor out the denominator, which is 62. We have 1, 62, because 1 times 62 is 62. And 2 and 31, because 2 times 31 is 62. But I cannot divide by 3 without getting a remainder when dividing by 3 into 69. So our factors for 62 are going to be 1, 2, 31, and 62. Okay, so next, write up the factors of 18 and 62 neatly in your notes, because it will be much easier for you to find the greatest common divisor and not get messed up. And so if you have scribbles and they're kind of all over the place, key thing is, you have notes, but then just have it nice and organized and list them chronologically factors so you can see which is the most commonly occurring factor. So you see here, so the factors of 18 are 1, 2, 3, 6, 9, 18. And the factors of 62 are 1, 2, 31, and 62. So the most commonly occurring factor for both integers is 2. So that is what we are going to divide by in this next step. Okay, step 2, dividing by the GCD, greatest common divisor. So we just factored out 18 and 62. So what's next? So we were presented with numerator A as 18 and denominator B as 62. We want to simplify 18 over 62 to its most simplified form, also known as the simplified fraction. We need to take those factors from the previous slide and find which one occurred most often. So as you can see, I see the 2 there and I see the 2. Now 1 occurred, but it is not the greatest value, right? So that's why 2 is the greatest common factor of A and B. 2 is our GCD in this case. This means we will have to divide the numerator by 2 as well as the denominator by 2 to reduce the fraction to lowest terms. What is 18 divided by 2? And what is 62 divided by 2? 18 divided by 2 is 9. So the numerator is now reduced to 9. 62 divided by 2 is 31. So the denominator is now reduced to 31. Your answer is 9 over 31. Congrats! You just reduced the fraction 18 over 62 to lowest terms. So if you have any questions, let's say I'm having trouble on this Euclid's greatest common divisor because I don't know the division facts. Go back to the beginning. Go back to your multiplication tables. Always backtrack, go back to the beginning and redo it. Okay? Or if you have a question on multiplying the improper fractions with a whole number, just leave it in the comment section and I can see what I can do to help, or in the next videos touch on those questions. Okay, until next time, I hope you do good on understanding all these fraction concepts. Until next time, bye.